All right, let's jump right into this explainer. Look, across the software industry right now, there is an absolute gold rush to integrate AI coding agents into our workflows. It's everywhere, right? And naturally, with all this new AI-generated code flying around at light speed, teams have developed an immediate, almost desperate reliance on dashboards to track exactly what these agents are doing. We all want to see the token streams, the drift logs, the evaluation pipelines, but today we're going to look at an incredibly compelling argument from NIMI HQ that suggests we might be fundamentally misunderstanding the very tools we're relying on.
Here is the roadmap for where we're headed today. We'll start with the observability trap, then look at the AI scaling problem, why visibility is not control, moving to governance before generation, and finally, we'll map out the complete AI stack.
Section 1. The observability trap, or when memory masquerades as control.
Okay, so the industry is currently making this quiet yet massive category error. Because, let's be real, instrumentation is just easier to build than enforcement. So teams are heavily investing in AI observability tools, and they're treating that investment as if it were actual governance. But there is a crucial, absolute dichotomy here. Observability is entirely post-generation. It detects and explains architectural violations after they have already happened. Governance, on the flip side, is pre-generation. It prevents or constrains those violations before the code is even written. Basically, observability is downstream and reactive, while governance is upstream and proactive.
By confusing these two concepts, we've ended up building AI coding stacks with incredible microscopes, but absolutely no gate. We have perfect visibility. We can debug token streams, we can deeply analyze agent behavior, but we are completely missing the essential constraint layer required to actually stop bad or non-compliant code from being proposed in the first place.
Moving to Section 2, the AI scaling problem and the underlying math of agentic development.
Now you might be wondering, why hasn't this lack of a gate destroyed our code bases yet? Well, at human speeds, reactive observability actually works totally fine. But with AI agents, we are talking about a 10 to 100 times increase. That is a massive multiplier in code generation volume when a single engineer uses an AI agent compared to your traditional non-AI baseline. And here is the kicker. Architectural drift accumulates at that exact same multiplier. We are quite literally generating code way faster than any reactive system can process it.
Let's break down the three compounding forces that make this drift so dangerous. First, as we just mentioned, is the raw generation rate. Second is session multiplicity. Think about it. Every cold-started session, every developer's local IDE workflow produces independent drift concurrently. And the third force? That's the bottleneck, review capacity. The human layer that actually has to sit there and read these observability dashboards remains entirely linear with team size. When you combine these three forces, your beautiful observability dashboard isn't a resolution tool anymore. It literally just becomes a rapidly expanding backlog generator.
So the crucial point boils down to this structural reality. You cannot fix a queue depth problem by simply improving the visualization of the queue. If your developers are feeling the pain of mounting architectural drift, it's simply because the queue is filling up too fast. To reduce that queue, we have to stop acting at the observation point and start acting upstream.
Section 3. Visibility is not control, also known as the failure mode.
I want you to imagine an engineering team with a perfect maximal observability stack. They trace every single tool call, they score every diff, and they surface every drift event in seconds. But they have zero governance, which raises a highly provocative question. Can you perfectly observe architectural drift and continuously ship it at the same time? The answer is unfortunately yes. You absolutely can. The agent proposes a violation, the dashboard beautifully records it, the violation gets merged, and the next session just proposes it all over again. The dashboard reports a perfectly stable drift rate, which exposes the fatal flaw. Dashboards merely record drift, they have zero mechanical power to stop it.
Which is perfectly captured in this quote from Theo Valmis. He says, "Observability without enforcement becomes operational archaeology." This is arguably the most important takeaway of this whole explainer. Visibility without restraint is really just a very precise, very expensive catalog of what already happened in your codebase. It offers absolutely no mechanism to change the future.
This brings us to Section 4, governance before generation, or shifting left of the LLM.
What we actually need is a corrective layer that sits directly in front of the agent. Here is the true definition of governance in the age of AI. It's the enforcement of machine-evaluable architectural decisions at the exact moment an agent decides to use a tool, before a single token of code is actually generated. Notice how explicitly different this is from prompt engineering. Prompt engineering just nudges the model and kinda hopes for the best. Observability just remembers what the model did. True governance mechanically prevents the violation from ever being written in the first place.
Now, for this to actually work, true governance has to have three distinct properties. First, it must be deterministic, meaning the same query must always yield the exact same architectural verdict. Second, it has to be propagated. Whether your developer is using Claude Code, Cursor, or Copilot, every single agent queries the exact same compiled rule set. And finally, it must be citable. When an agent gets blocked, it needs to trace directly back to the original architectural decision record, the authoring rule, so the human engineer knows exactly why it happened.
Now, I want to be very clear here. This absolutely does not mean observability tools are useless. Not at all. Think of it like this. Observability is operational memory, while governance is operational control. You need both to create a functional feedback loop. Observability actually becomes infinitely more valuable when it's paired with a governance layer, because governance suppresses all that routine noise and preventable drift. That leaves your observability dashboards clear to highlight the genuinely interesting edge cases.
And finally, Section 5, the complete AI stack, the 4 layers.
Let's take all these concepts we've talked about and build a comprehensive architecture that perfectly balances proactive constraint and reactive memory. Imagine a single AI prompt passing through this pipeline. First, governance constrains the agent's intent. Second, verification confirms architectural invariants hold up against the proposed output. Third, observability detects any slips that somehow made it through. And fourth, review relies on humans to escalate the final edge cases.
Having all 4 of these distinct layers is an absolute necessity. If you read top to bottom, you can see how each layer beautifully compensates for the residual signal of the one directly above it. Governance handles the bulk mechanically. Verification double-checks the work. Observability surfaces whatever slipped through the cracks, and review judges that final tiny minority of edge cases. If you're missing the top 2 layers, your team is quite literally paying the full human cost for every single AI violation.
To really cement this into actionable architectural decisions, let's map these theoretical layers to real-world tooling categories today. For generation, you have tools producing code like Cursor or Copilot. Then you have your governance layer, like Meme, which is actively constraining intent. Next is your observability layer, using tools like Langsmith, Braintrust, or RIs to explain the outcomes. And finally, your review layer, utilizing CodeRabbit or human reviewers to handle the final escalations. Every layer does exactly what it's best suited for and nothing else. That is a configuration that actually scales.
So I want you to look at your own pipelines today. Is your AI tooling stack actually providing operational control and stopping drift before it happens? Or are you paying for massive dashboards that simply record your own operational archaeology? Think deeply about that as you continue to scale your AI development. Thanks for joining us for this explainer.